Okay, so this is gonna kind of be a tricky one. It's about this thing called bearing, which basically is a way to give good directions. Like if you're looking at my warm-up, it's supposed to make you explain how to sail this boat around a buoy so that a blindfolded boat captain could do it. My directions that I'm jotting down, just like, hey, let's go 25 miles, let's go 10 miles south, and then let's kind of go southeast-ish. Those would not be very good directions. So, bearing is how you can give good directions in navigation. It can be given two ways, either as a single angle or as like a direction, an angle, and then another direction. So like the first way, you could be given 120-degree bearing. So you draw yourself a little north line and then an angle going 120 degrees clockwise from it. Way number two, say you've got like south 30 degrees east. You would have a line going directly south, and then from that south pointing line, you'd go to the right, because that's our easterly direction, 30 degrees up, and that would be your bearing for that second expression. So the key is going to be to draw good pictures. So first situation, we have two radar stations, A and B, on an east-west line, 8.6 kilometers apart. They both detect the same plane at two different bearings. We're supposed to find the distance from B to C. Okay, so first off, let's draw our east-west line. So stations A and B are on this east-west line, and they are 8.6 kilometers apart. I'm going to put station A on the left side at the west and station B on the right. If you get them backwards, you'll realize because your picture won't make any sense. So putting them there, if I draw a line going like directly north, since it says my bearing is 53 degrees towards my plane from station A, go 53 degrees from that north line in a clockwise direction. And then if I draw a little dash line out here, if I'm looking in that direction, I should look up and detect my plane from my radar station. So somewhere along that line is my plane. So from radar station B, I've got my bearings 323 degrees. So just past 270 there would be my 323 degree angle. And again, the end of that line is where my plane's going to be. So where my lines of sight meet, I've got plane C there. So now what I need is my distance from B to C. Using kind of that triangle that I ended up with in the middle, I'm going to need to figure out some angles inside of my triangle, so I'm going to redraw this triangle down below in kind of like a simplified version. So I know the distance from A to B is 8.6 kilometers. And if I think about that angle in the lower left corner, my north-south line and my east-west line are perpendicular. So if I subtract 53 degrees from 90, that'll give me my leftover angle is 37 degrees in the lower left. So if I think about in the lower right, I went a little bit past 270 degrees. So if I take my 323 and subtract 270 degrees from it, that tells me that's a 53 degree angle in the bottom right of my triangle. You could get there from like 360 a different way too, but that's just the way I did it. So if you add those two angles up, they're 90 degrees, which means angle C is a 90-degree angle, which we need to do any of this trig function values. So I'm going to set up a trig equation looking for the distance from B to C, which I'm going to label as x. So you could do sine of 37 degrees would equal x over 8.6. You could also do cosine of 53 degrees equals x over 8.6 and get there that way too. So if you multiply by 8.6 and punch it in your calculator, you get approximately 5.18 kilometers for a value of x. Let's try another one. So this is the second version of bearing where you've got a north-south angle and then some amount of measure coming from it. So I'm going to start with point A here, and then this one is from a north direction, 64 degrees west or to the left. So point C, I'm looking towards, has to be on that line somewhere. We don't know exactly where till we draw the rest of our picture, but point C is on that line somewhere. Second piece of information is we've got the bearing from A to B is south 82 degrees west. So again from point A, but this time from a south direction line. we're going to go 82 degrees west, so up there. And then I know that point B is somewhere along that line. Again, we don't know exactly where. If we look at our third piece of information, it's about how our bearing is from B to C. So I'm just going to pick somewhere and put B on that line. It may or may not be to scale, depending on where you pick it to be, but I'm going to say it's right there. And then if I draw in my northerly line to go towards my bearing for C, it's 26 degrees east from that line. So drawing my angle out here, as I look from B to C, it's got to be right there. So that puts point C at that red point on my line that I knew C was on somewhere. Okay, so we've got a triangle in the middle. We've put some things together. Let's figure out the angles in that triangle, because we're going to need those before we can really figure out the rest of our problem. So I'm going to redraw it again over here to the side. And this is going to take a little bit more thinking to figure out some of our angles. So I'm going to go ahead and draw in like the south part of that one line, because I'm going to use some facts about parallel lines, because both those north-south lines are parallel. I've got some alternate interior angles right there. So if that angle is 82 degrees in the highlighted green bottom right of my first picture, then the total angle above in the left has to be 82 degrees also. So if I take my 82 degrees and subtract 26 degrees from it, that's going to get me the angle in the triangle that I actually want. So 56 degrees. Okay, I'm going to do a little bit of erasing because my picture's going to get really complicated. Same idea. For the bottom right, those two angles that I shaded are alternate interior. So I think that whole now north-south line is 180 degrees, and I subtract 82 degrees from it. That gets me my shaded part is 98 degrees. And then again, alternate interior angles is equal, so that part's got to be 98 degrees too. 98 minus 64 degrees gets me that little leftover angle in my triangle is 34 degrees. And hooray, that means my last angle is a 90-degree angle, which it has to be, or we're going nowhere until we get to, like chapter 7, and we can deal with it then. But right now, it should be a right triangle. Things that we know for lengthwise, we know distance equals rate times time, and they told us it takes 1.8 hours at 350 miles an hour to go from point A to point B. So if you multiply those together, you can get your side length in your triangle is 630 miles between point A and point B. So our hypotenuse that we drew down there is 630 miles. And then if we solve for x, which is the distance from C to B, we can use another trig equation. So I'm going to go sine of 34 degrees would equal my opposite side x over my hypotenuse of 630. Again, you could go with a different trig function if you wanted to. Multiply that over, and you'll end up with the distance between C and B is about 353.29 miles. One more, because I was way overthinking this one until I actually tried it. So again with the planes, this plane is flying at a bearing of 38 degrees, and then it's turning and flying for a little bit longer at a bearing of 128 degrees. So there's kind of my plane's path that I threw up there. We're supposed to figure out how far this plane is from its starting point. We have a couple of distances already. If we multiply distance equals rate times time, we can get that its first path was 143 miles and its second one was 165 miles. But what we need is how far did it end up away from where it started. So that distance right there, which is not like a horizontal line or anything, at least not for sure. So we need to figure out that. If you kind of extend this north line in the middle here, and again, think about alternate interior angles and some other facts. Actually, to start with, let's go, hey, that's 180 degrees, that north-south line. So if we subtract our 128, that gets us 52 degrees to start with right there. Sorry, I jumped ahead of the gun with the alternate interior angles. Now we're going to use some alternate interior angles. So back to the, if you extend that out and think those north-south lines are parallel, that angle and our mystery little angle on the left side are alternate interior angles. So that little piece has to be 38 degrees too. And then if you add those two together, you're going to get this super important fact that that is in fact a 90-degree angle up in that little corner of our triangle in the middle there, our big triangle. So let me, in my favorite form of working these, redraw it. So that's 90. One side's 143 degrees, one side's 160, not degrees, whatever we're measuring things in, miles. It's too late for this. You can use the Pythagorean theorem to figure out your value for x. If you have two side lengths, this is a right triangle, just good old Pythagorean theorem. So if you plug those values in, take the square root of it, you're going to end up with approximately 218.344 miles for that distance. Outtakes, my cats were running around like crazy when I was trying to record that audio. So I blame all my distractions and misspeakings on them. Also, thanks for being good sports and trying to stick with me here, because I know it's been a lot of snow days and a lot of trig on your own. So let me know if you have questions, because this section was definitely kind of tough.